In this lecture, we'll cover the concept of time dilation. Let us take a situation where there is a compartment, a train compartment moving with a velocity v along this platform, and v is the speed of this compartment. Sam is sitting inside the compartment and Sally is on the platform. There is an event which happens here in the compartment. A pulse is generated and it goes straight, comes back, and the clock which is there with Sam will measure the time by this relationship. C is the speed of light, d was the distance. Since light goes and comes back, this is the mirror, it goes and comes back, so C is twice d upon t, or d can be written as ct upon 2. So the Sam measures the time t and we take this time as the correct time, t0. Though in relativity there is nothing called correct time, it is all the reference frame. Now we are taking correct time as the time where the place of the event does not change. So event was happening here in this compartment and here the time is measured. This is t0. Now there is another person called Sally. For him, see how the event happens. Now at time t1, t is equal to t1, the pulse is generated. But since the compartment is moving, pulse of light, we know the light is moving in all the directions. From here the pulse is moving and the mirror is somewhere here. When the pulse strikes the mirror, as far as Sally is concerned, so it strikes here and gets reflected and comes back as far as Sally is concerned. So the location of the event is at two places. Where the pulse is generated, it is at this point, and where the pulse is received is at this point. So he measured the time, he measures the time t for this event at two different locations. This is the whole crux of the time dilation, why this difference is happening. Here the time is measured at the same place where it occurred, there the time is measured. But here the time is measured in a frame which is not moving. So for Sally, this event is happening at two locations, means pulse being generated and pulse being received. These are at two different locations. Now let us see how much is the distance traveled by the pulse. If this is d, let this be L and this be L. Total distance is twice L, and speed of compartment is v will be equal to twice L upon t. This is the time measured, t1 and t2 at two locations. So let this be the time t which the Sally measured for the same thing which has happened, for the same event. But for Sam the event happened at the same place. For Sally the event happens at the two different locations. The time is t. Now see what is the distance traveled by light. It will be, this is d square plus L square root. So distance traveled by light is twice under root d square plus L square. Now if you take again the same relationship, the speed of light is c, so the distance is twice root d square plus L square, and t is the time. As far as Sally is concerned, he is measuring the time as t, so we write it as c square t square is equal to twice, or we have squared it, 4 d square plus L square. Now place the value of d and L. D was how much? D square is c square t0 square upon 4, and L square would be equal to v square t square upon 4. So place the values here, it becomes 4 c square t0 square upon 4 plus v square t square upon 4. So c square t square becomes c square t0 square plus v square t square. Bring t on the same side, so it becomes t square. C square minus v square is equal to c square t0 square. So take the square root, divide by c square. So this becomes t is equal to t0 divide by square root 1 minus v square upon c square. We call this as gamma. And since this is less than 1, so t is greater than t0 because this denominator is less than 1. This is what is time dilation. The time measured by the person who is at the same place where the event is mentioning. See, the Sam remains in the compartment. For him, the event is happening at the same location. But for Sally, he is not moving. The compartment is moving. For him, the event happens at two different locations. He measured it at T, and Sally measured as T, and Sam measured as T0, and T is greater than T0. This is what we call as the time dilation.